This is number 111 in problem solving. And what we have is a very small number, and we're trying to figure out how many zeros will this number have before you hit a number. That's what we're trying to figure out, is the number of zeros. So when I have a very small number or a very large number, I always think about scientific notation. So scientific notation is some, or form of it, some number times 10 to some power. The key is the 10. So here I have 1 over 2 to the ninth. I'm going to leave the times out. And then a 5 to the third. Well, you see how you have a base of 2 and a base of 5? And that makes me think of 10. Now I only have 3 5s. So I want to put those 3 5s with 3 of the 2s. I can't put any more 2s than that because I only have 3 5s. Of course, that leaves me 6 2s left over. So now I have 1 over 5 times 2 to the third. I'm going backwards because that's understood to be a 1 there and a 1 there. If I was to get rid of my parentheses, when you have power to power, you multiply. In other words, if you have x to the a to the b, that's x to the a times b. So I've just rewritten that, and I still have my 2 to the 6. So now I have 1 over 5 times 2, of course, is 10 to the third times 64. That's 2 to the 6. Now this 10 to the third in the denominator, that's just going to make your number smaller. I need to figure out what is 1 divided by 64. That's 1 divided by 64. There's your decimal. Put your decimal up there. Add a 0. 64 will not go into 10. That's a 0. Add a 0. 64 will go into 100 one time. That's good enough. So now I have 0.01 over 10 cubed, which is the same thing as 0.01. Bring that 10 cubed to the numerator, and that changes the sign of the exponent. It turns into 10 to the negative 3. And when you multiply by 10 to the negative 3, what that does is move your decimal point 3 places to the left. So now what I have, this one, you can move it 3 places to the left. So that would be 3 zeros, and then you still have 0, 1. So how many zeros do I have to the right of the decimal point? 1, 2, 3. I have 4.